Welcome to solving radical equations and inequalities. Today's objective is to solve radical equations and inequalities. In this section, we're going to take radical equations and solve for them. So we're going to start off working with some simple ones such as x squared equals 9, the square root of x equals 7, and the cube root of x minus 2 equals 0. Okay, the main idea for a lot of these equations is to get x by itself, basically isolate it, and then get rid of any radical notations. So for this first problem, we have x squared equals 9. Now I have to get x by itself, so what I have to do is take the square root of each side. When I do that, I'm left with x equals plus or minus 3. For the second problem, I have the square root of x equals 7. Now to get rid of the radical symbol, what I have to do is I have to square both sides. Now when I do that, that eliminates this radical symbol here, and I'm just left with x. And that's because the square root of x times the square root of x is just x. So I have x equals 7 squared. So x equals 49. For a third problem, we have the cube root of x minus 2 equals 0. So we have to isolate the cube root of x and move 2 to the other side. Now I want to get rid of this radical symbol, so what I'm going to do is I'm going to raise both sides to 3. So when I do that, I have x on the left side, and then I have 2 cubed. 2 cubed equals 8. So these are pretty simple examples, but this is the main idea. You want to get x by itself, and then remove any radical or exponent notations that that variable has. Okay, now let's solve equations with one radical. So let's start with example A. So for example A, I have 2 times the square root of x plus 1 equals 14. So the first thing I want to do is try to isolate x. So I'm going to do that by dividing by 2 on both sides. So my equation is 2 times the square root of x plus 1 equals 14. I'm going to divide both sides by 2. After that, I'm going to have the square root of x plus 1 equals 7. My second step is to eliminate the radical in this equation. So to do that, I have to take each side and square it. So I have my equation x plus 1, the square root of it equals 7. So I take each side and I square it. When I do that, what I'm left with is x plus 1 equals 49. And then I just solve for x, and x equals 48. Let's look at example B. Example B is very similar. First thing we want to do is to get rid of this 5. So we're going to divide both sides by 5. When we do that, we're going to have the cube root of 4x plus 3 equals 3. Now I want to eliminate the radical notation, so I'm going to raise both sides by 3. When I do that, I'm left with 4x plus 3 equals 3 to the third. I know 3 to the third is 27, so I'm left with 4x plus 3 equals 27. Isolate x, so I have 4x equals 24 divide both sides by 4, and x equals 6. Now let's work on solving equations with two radicals. So for our first problem, we have the square root of 35x equals 5 times the square root of x plus 2. So the initial idea is the same. We're still trying to isolate x. But it's an equation, so what we do to one side, we have to do it to the other side. So I have the square root of 35x, and I have 5 times the square root of x plus 2. What I'm going to do is I'm going to square both sides. Now what that does is that gets rid of the radical, which is cool, that's what I want. So after I do that, I have 35x equals 25 times x plus 2. Now we're in good shape. This is a pretty simple algebra problem. So I have 35x equals 25x plus 50. Subtract 25x from both sides. I'm left with 10x equals 50, x equals 5. For the second problem, same idea. What I want to do is I want to get rid of that radical symbol. So I'm going to take both sides and raise them to the third. On the left side, I'm going to be left with x plus 6. And on the right side, I'm going to be left with 8 times x minus 1. Pretty simple algebra. X plus 6 equals 8x minus 8. Swing over this 8 to the other side, I'm left with 14. Subtract x from both sides, I'm left with 7x. Divide both by 7 and x equals 2. Now you can check either one of these by taking this and plugging them back in right here and right here. If I plugged it in, I'd have the cube root of 2 plus 6, which is 8, equals 2 times the cube root of 2 minus 1, which is just 1. The cube root of 8 is 2. The cube root of 1 is 1. So 2 equals 2. Our solution is good. Now, sometimes when we solve our equations, we're going to end up with extraneous solutions. So let's see how this solution works out and see if we can plug it back in. So I'm trying to solve for x here, but I want to eliminate the radical. So my first goal is to eliminate the radical. So I have x plus 18 equals x minus 2. So to get rid of the radical, I'm going to square both sides. My left side's easy. That's just going to be x plus 18. But the right side I have x minus 2 squared. So that's x minus 2 times x minus 2. So I distribute my right side, and I'm left with x squared minus 2x plus 4. So I have x plus 18 equals x squared minus 4x plus 4. Now since I want to solve for this, let's put it all on the right side. So I'm going to have x squared minus 5x minus 14 equals 0. So I just subtracted the x and the 18 from the left side. Then I factor this, and I have x and x. I need 7 and 2. My 7 needs to be negative. and my 2 has to be positive. So my two values of x are x equals 7 and x equals negative 2. So now let's check these solutions and see if they work. So let's try x equals 7 first. If I plug in 7 to our original equation, I have the square root of 7 plus 18 equals 7 minus 2. 7 plus 18 is 25. 7 minus 2 is 5. The square root of 25 is 5. 5 equals 5, that works. Let's try our second solution. So we have the square root of negative 2 plus 18 equals negative 2 minus 2. 18 minus 2 gives us 16. And negative 2 minus 2 gives us negative 4. The square root of 16 is 4, and that does not equal negative 4. So x minus 2 is an extraneous solution. So sometimes we do have to check to make sure that these solutions work. Now let's solve some equations that are written with rational exponents. Now the only difference here is instead of having an equation such as find the cube root of x minus 2 equal to 0, rational exponents will write this as x to the 1/3 minus 2 equals 0. The idea is very similar. We have to get rid of either that exponent or that radical symbol. So let's look at example A. Example A, we have 3x minus 1 raised to the 1/5 equals 2. So if I want to get rid of that 1/5, what I have to do is raise both sides by 5. So I have 3x minus 1 raised to the 1/5 equals 2. So I have to raise both sides by 5. And when I do that, I have 3x minus 1 raised to the 5 over 5 equals 2 to the 5th. Now 5 over 5 is going to simplify to 1, so I'm going to have 3x minus 1 equals 2 to the 5th, which is 32. Then I can isolate the 3x and have 3x equals 33. So x equals 11. Let's try example B. For example B, I have x equals x plus 12 raised to the 1/2. So what I need to do is, to get rid of that 1/2, I raise both sides by 2. Then I have x squared equals x plus 12. I want to put this in standard form. So I have x squared minus x minus 12 equals 0. Then I just factor. So I have x and x. I need 4 and 3. 4 should be negative, 3 should be positive. And then my answers are x equals 4 and x equals negative 3. And that's how we solve rational exponents. Okay, let's try one now with a number in front of the parentheses, but the idea is similar. You want to isolate the x plus 6. So the first thing you would do is divide both sides by 3. Then you're left with x plus 6 raised to the 1/2. And that's going to equal 3. Now I want to get rid of the 1/2, so I have to square both sides. When I do that, I'm left with x plus 6 equals 3 squared. 3 squared is 9. X equals 3. And I can check that by plugging it back into my equation. So I have 3 times 3 plus 6 raised to the 1/2 equals 9. I combine these terms, I'm left with 3 times 9 raised to the 1/2 equals 9. 9 raised to the 1/2 is 3. And 3 times 3 equals 9. Alright, well that's the end of our video. Thank you and take care.